Hi everyone. We have lesson 4.4. There's just one video for today's lesson, and this is doing what we call the difference of squares, which is another factoring strategy for a specific situation. So this is just the investigation part of this. So if we have a sum of -6 and a product of -16, the numbers that get us that are 2 and -8. So the polynomial there is x squared minus 6x minus 16. And when I factor that, it becomes x plus 2 times x minus 8. Not really sure what the point. Oh, I guess the first two are just practice. So here we have 1 and -16. So x squared minus 15x minus 16, and so we get x plus 1, x minus 16. Okay, that's just old news. What if the sum is 0? Well, the sum can only be 0 if our product is negative, because our integers that we factor to are going to be the positive and negative version of the same number, because then, 4 minus 4, 4 plus -4 equals 0. So this gives us, if we were to write it in the regular trinomial form of x squared plus 0x is minus 16, and then we simplify that to x squared minus 16, and you can see we call this a difference of squares because this is a perfect square, this is a perfect square, and it's subtracted, which means it's a difference. Okay, that's where the term difference of squares comes from. And so from that, because we know these numbers over here, we factor this as x plus 4, x minus 4. And here, same thing, because the middle term is 0, the sum is 0, we have to have our two integers have to have the same number, same absolute value, or same distance from 0, but one's positive and one's negative, so this is going to be 8 and -8, and so that comes out to x squared plus 0x minus 25, which we simplify. Sorry, it looks like I wrote that as a not equal to, but I didn't. So that equals x squared minus 25. So if we have x squared minus 25, we factor that to x plus 5 times x minus 5, just like that. Okay. Sorry, I was on the question below. X squared plus 0x minus 25 equals x squared minus 25. Oh, forgot it. Go back and fix that. Okay, this one, again, we've got a sum of 0, so our two numbers need to be the same, the number, but one positive, one negative. And it's going to be the square root of this, because that's what we need to have to multiply to get the 64 part of it. So it's going to be 8 and -8. So this is x squared plus 0x minus 64, which equals x squared minus 64. So if we have x squared minus 64, we can factor that as x plus 8, x minus 8. And then the last example here, we end up with 5 and -5, so x squared minus 25. And then we factor this as x plus 5, x minus 5. Now, does it matter if you put the plus first or the minus first? No, it doesn't. I always do the plus first. There's actually a reason for that, and there's actually no questions like that in this practice work, but I'll show you at the end of the lesson. Okay, I'll do an example of it at the end of the notes. Okay. All right. The third row in A above shows that the factored form of x squared minus 16 is x minus 4 times x plus 4. So the pattern is, just to be really explicit here, we have x squared minus 16. So we go, it's the square root of this, which is x, plus the square root of that, which is 4, times, maybe I'll do this in a different color, times the square root of that, which is x, minus the square root of that, which is 4. So it's the square root plus and minus. Okay? So this is going to be x plus 3 times x minus 3. That's it. That's the whole difference of squares. That's all you do. So this is going to be x plus 7, x minus 7. Okay? You go ahead and do these ones and then come back and check them. Okay? X plus 6, x minus 6, x plus 1, x minus 1, a plus 10, a minus 10. So anytime you have a difference of squares, that means that your first, it's a binomial, 2 terms. First term is a perfect square. Second term, ignoring the subtraction between them, it's got to always be a minus. And then the number at the end, or whatever the expression at the end is a perfect square. Then we can do this. You can also factor it by looking for the product of whatever and the sum of 0. You can do that as well. It does work, but this is just so much faster. Okay. So let's extend this procedure above to factor this one. So m squared minus n squared would factor to m plus n times m minus n. That's just following the pattern. And then it says to verify it by expanding it. So m times m is m squared. M times negative n is negative or minus mn. And then we have plus mn and then minus n squared. And then you'll notice that we have minus mn plus mn, which equals 0. So that just goes away. And we're left with m squared minus n squared. Okay. Consider this expansion. Explain why the value of b is 0. The middle terms cancel out, just like we just saw. And express c in terms of y. C equals negative y squared. Right? That's that. Now there's on this next page here, there's some drawings to show you just graphically why this happens. I'm just gonna, you can read over this if you want. I don't think that me reading it's gonna help you. Yeah. Okay, and then let's factor some more, okay? So you know how to do this. It's a plus 2 times a minus 2. Pause it and do the rest, okay? T plus 12, t minus 12. X plus y, x minus y. P plus 7, p minus 7. My 7s don't look very good these days. Okay, very, very important. You cannot do this with a sum of squares. If it's got a plus in the middle of it, you cannot do this because those middle terms don't cancel out. You can't find two integers who have a product that's positive and a sum of 0. Okay, doesn't exist. Okay, and then this is just, this next part is just sort of making this a tiny bit more complicated, where instead of just having x squared, we have 4x squared. Okay, but it's the same thing. We're going to take the square root of this first piece. So the square root of 4x squared is 2x plus the square root of 25. And then same thing with a minus. That's that. Okay, and here, same thing, square root of 9m, so 9m squared is a perfect square, minus 4n squared is also a perfect square. And so this is going to be 3m plus 2n times 3m minus 2n. Okay, that's it. Nothing very complicated there. So just some more practice or examples of this. So let's do the first one together, and then you can try the other ones on your own. So I've got 4t plus 7 times 4t minus 7. Okay, go ahead and do these on your own. 81a plus 1. Nope, that's wrong. Sorry. Oh, sorry. Let's try that again. This is going to be 9a plus 1 times 9a minus 1. I was just thinking while I was doing that like 1 is a perfect square. It's just 1 times 1. Its square root is the same as it. But it only works for 1s, doesn't work for 81. This is going to be 10 plus y times 10 minus y. This is 6p plus 5q times 6p minus 5q. 2x. Oh, can't factor because it's got a plus. Okay, can't do it. And the last example is 8 plus 3ab times 8 minus 3ab. Okay, now here's one of these weird word problems that this book does. What we're just going to have to do for these questions is that when it tells us that this is the area of something, and it asks for the length and the width, we're just going to assume that however we factor this, there's only going to be one way to factor this, and that is going to give us the length and the width. That's the only thing that makes sense, okay? So my length is going to be, since 25a squared minus b squared equals 5a plus b times 5a minus b, and we're just going to assume that a and b are both positive, because why not? I'm sure it would work out. The signs would just change and it would come out the same. But this one looks bigger than this one, so I'm going to call this one my length. Not that it really matters, but my length is going to be 5a plus b, and my width is going to be 5a minus b. Let's make that a little prettier. W equals 5a minus b. And then the perimeter of the floor is 140 feet. Find the length and the width if the length is 1.8 times the width. Okay, well, I have my perimeter equals, I can do 2 times L plus 2 times the width, or I can say that it's 2 times the length plus the width, and that's actually going to be easier in this particular case, I think. And I know that my perimeter is 140. So 140 equals 2 times 5a plus b plus 5a minus b. So my b's are actually going to cancel each other out. So I get 140 equals 2 times 10a. So 140, 140 equals 20a. And I divide that by 20, and I divide that by 20, and I get 7 equals a. So my a is 7. And then I know that my length equals 1.8 times my w. And since my length equals 5a plus b, that equals 1.8 times my w, which is 5a minus b. And then I know that a equals 7, so I can substitute that in. So this is 5 times 7 plus b equals 1.8 times 5 times 7 minus b. So I get 35 plus b equals, this is a times and this is a decimal. That comes out to 63 minus 1.8b. And then I'm going to add 1.8b and add 1.8b. So I get 35 plus 2.8b equals 63. And I subtract 35 and I subtract 35. And I get, come back up here. Oops, that's supposed to be an arrow. 2.8b equals 28. So divide by 10, divide by 10. Sorry, I got the answer in my head. I'm going to divide by 2.8. And b equals 10. Okay, so I have my a and my b. So now I can figure out what my length and the width are. So my length equals 5a plus b equals 5 times 7 plus 10. So my length equals 35 plus 10 is 45 feet. And my width equals 5a minus b, which is 5 times 7 minus 10, which is 35 minus 10, which is 25 feet. Okay. And I should probably check my perimeter. If I add those two together, I get 70, and if I multiply that by 2, I get 140, so that's awesome. Okay, one more little set of examples where there's a common factor. So when we look at this, and it's not immediately visible. It's that it's a difference of squares. But the first thing I always do when I'm looking for factoring is I always look for the common factor first, and I'm always going to take out the greatest common factor first. That's just an always. So I'm going to do that. So I've got a common factor of 2, so this becomes 2a squared minus 25. This is a perfect square, so this becomes 2 times a plus 5 times a minus 5. Okay? This one, greatest common factor is 3. This is 3x squared minus 4y squared. Hey, that's a perfect square, or difference of squares, so that's 3 times x plus 2y times x minus 2y. Try the last two on your own and come back and check them. 144 divided by 4 is 36. So I've got 4 times 36 p squared q squared minus 1 equals 4 times 6pq plus 1 times 6pq minus 1. Don't try and do it all in one step, okay? I mean, you might be able to do it, but it's just not worth it, okay? It's just not worth the possibility of making a mistake for most of us. Most of us mere mortals. Okay, greatest common factor here is 3x. So I'm going to divide everything by 3x. I get x squared minus 9. Hey, look, those are both perfect squares. So this is 3x times x plus 3 and x minus 3. Okay. Now, I promised you I was going to show you just an extension on this and why I do the addition instead. Do the addition first. What if I had, let's say I've got 81 x to the 4 minus 1. Let's just go with that. I'm going to factor that. Okay. This is a perfect square. This is a perfect square. So this is going to be, my square root of this is going to be 9x squared, right, plus 1. And then 9x squared minus 1, right? 9 times 9 is 81, x squared is x to the 4, 1 times 1. Yep, we're good. Am I finished? No, because this is also a perfect square. And so this one I can't factor because it's a sum. Nothing I can do with that, but I'm just going to write it right underneath, okay? And then I'm going to factor this one, and this is going to shove it out to the right a little bit. So square root of this is 3x plus 1, 3x minus 1. So basically the reason I do the plus first is so that if this happens, at least part of it is directly underneath where it was. instead of having this first and this part shoved over. Anyway, it doesn't matter how you do it. I'm just sharing why I do it this way. You will be expected to do a question like this. I will just make sure that there are some in the review. Okay, or maybe I'll add them to tomorrow's class because it's a review of factoring. All right, that's it for the lesson. Take care. Bye.